Hello, my friends, and welcome to this quick revision in your favorite subject, chemistry. This is the 9th class, and in this class, we are going to revise what we have taken so far, and we are going to answer new questions. First of all, allow me to revise what we have taken so far. First of all, we defined the atom as the smallest part of any chemical materials that cannot be divided into two more identical parts anymore. And we said that the atom, in terms of structure, is made up of two main parts. The first one is called the nucleus, and inside which there are two types of nucleons. The first one is positively charged, and we called it the positive protons, and the other one was called the neutral neutrons. Then the other part was the electron shells, or we call them the energy levels, and inside which we could find only negative electrons. Then we said that the last shell is called the valence shell, and the valence shell is the responsible for the charge of the atom. Generally, the atom is neutrally charged, meaning the number of positive protons is equal to the number of negative electrons. When the number of electrons changes, we call, and it is not equal to the number of protons, we call the atom now an ion. Then we said that we have two types of ions: positive ions, cations, or negative ions, anions. And then we again, an element is a group of atoms that have the same atomic number of protons in their nuclei, and go through the same chemical reactions. And we said that atoms are different from one another, and they make different elements because they have different number of protons. Again, every group of elements that have the same number of protons are going to be called one element. And then we said that every element, atoms, share the same number of protons, and they are different, which is different from the number of protons shared by the other atoms of another element. For example, every copper atom in the world has 29 protons, every iron atom has 26, and every gold atom has 79 protons inside its nuclei. Then after that, we have talked about some atoms called isotopes. And we said that isotopes are the atoms of the same element, meaning they share the same number of protons, or the atomic number, but they have different numbers of neutrons. For example, we have iron here, 26, 56, meaning that this atom of iron has 26 protons and 30 neutrons, and the total mass number is 56. The other one is 57, meaning that this iron atom has 26 protons as the other iron atoms, and has 31 neutrons, which makes it heavier than its sister, let's say. And the other one here has 32 neutrons and 26 protons, and the mass number, which is the total number of protons and neutrons inside the nucleus, is 58. So are those atoms different chemically? Chemically, they are the same because they go through the same chemical reactions and they belong to the same element, but they are different in terms of their masses. One of them is heavier than the other, and this one is heavier than those two each. Now, my friends, let's understand the advantages of knowing isotopes. Why scientists were interested in studying isotopes? Answering the questions of Class 9 and Class 10 are going to give you the best answer for this question. Now, my friends, after this quick and brief revision, let's answer the questions of the 9th class. First question is, what is the mass number? Actually, the mass number represents the total number of nucleons inside the nucleus. And of course, when I said nucleons, I meant the total number of protons and neutrons inside the nucleus. So what is the atomic mass? Generally, the atomic mass is a new term which emerged after this question which was asked by scientists. We all know that atoms are different from one another. Of course, atoms or elements are different from one another because they have different numbers of protons and neutrons inside their nuclei. For example, copper has 29 protons, iron 26, and gold 79. So those atoms are different from one another in terms of the number of protons and neutrons inside their nuclei. Also, the number of neutrons inside the atoms of the same element, or we call them the isotopes, are different, although they have the same atomic number or the number of protons. So there was a necessity to find a unit of measurement to measure the mass of every atom by itself. Actually, we started this using AMU. So what does the abbreviation AMU stand for? It stands for atom mass unit. Well, AMU, or atom mass unit, was put in order to be our scale to measure the mass of an atom. Allow me now to explain how do we use it. We said that the mass of one proton is nearly or approximately equal to the mass of one neutron, which is equal to AMU. So we started measuring from the subparticles which are in the nucleus. And then we said that the atomic or the mass number is the number of protons and neutrons inside the nucleus. So the mass, the atomic mass, is going to be the mass of all nucleons, all protons and neutrons inside the nucleus. So if you want to measure the mass of one atom, you should go and find how many protons and neutrons inside it. Then you are going to say that its mass is going to be equal to this number. Now, my friends, one of my students asked me this question. Teacher, maybe you forgot to say something. As you know that an atom is not only made up of protons and neutrons, there are electrons. For example, in here, in the gold atom, you have 79 protons, which means that there are 79 electrons. Teacher, in your calculations, you are ignoring the mass of 79 electrons. Is this possible, and why? I said yes, it is possible, and we should ignore the mass of electrons in our calculations to calculate the mass of an atom. Allow me to explain why with a very small example. First, let me tell you about the mass of every subatomic particle inside the atom. First of all, we said that the mass of one proton equals the mass of one neutron, approximately, of course, which is equal to the mass to 1 AMU. But what about electrons? We have found that the mass of one neutron or the mass of one proton is equal to the mass of 1,837 or 34 in other references. So what is the relationship here? The relationship is the mass of one electron is going to be 1 over 1,834 proton or neutrons. So we need 1,837 electrons in order to have the mass of one proton or one neutron. Let me give it to you in another way, the number methodology. Let's take the atom the student discussed me about, and we try to calculate its mass. We have protons and neutrons here. What are the subparticles? Subparticle. Protons and neutrons, we have the weight or their mass, let's say not weight, let's say the mass. The mass is 1. Multiply 196, it's 196. What about the mass of electron? The mass of an electron is 1 over 1837, and it is going to be approximately 0.04. Now, my friends, if we want to calculate the total mass of this atom, is going to be 196.04 AMU. So if I say it's only 196 AMU, does it make any difference for you? It is nearly 1 over 1834 of the total mass, and it's not important, and it is very small, so that we ignore it. Now, my friends, let's take another example to make our point clearer. So let's calculate the mass of this atom. And as you know, in here we have protons and neutrons. The mass is 1. How many protons and neutrons do I have? Yes, I have 56. And it's going to be here 56. What about this one? How many electrons do we have? We have 26 electrons. Multiply 1 over 1837. It's going to be 0.15. So the total mass is going to be 56.015. Actually, we can say that the atom, the mass of this atom is 56 AMU, because we can ignore this very small amount in here. Well, my friends, that's it for today. I hope you enjoyed this class, and please don't forget to play this video again if you don't understand, and try to play some Kahoot games which are related to our topics today. Thank you again, and I hope I will see you next class in order to continue our classes. In the next class, my friends, we are going to talk about relative atomic mass, and we are going to compare the atomic mass with the relative atomic mass to see the difference between them. Till then, I wish you all the best, and I hope I'm going to see you fine and well, and thank you so much, and goodbye.